want to welcome you. We're going to talk about tailwheel flying. I'm probably not the most experienced tailwheel flying person, but I have a tremendous amount of variety in probably the 1,500 hours of tailwheel flying and tailwheel teaching. Everything from, believe it or not, gliders that are tailwheel but don't require a tailwheel endorsement, all the way up to things like Beech 18s. So in anything in between, including many experimental aircraft. But I am not the full expert, and many of us, we try to, in the FAA, gather together and take as much as possible. So I reached out to Tim Haley, who's from the Greensboro FSDO, and he's going to be joining us tonight too. There is my contact information. There's where you'll see. That's what I will be doing tomorrow, flying in L19 to tow gliders up. I'm on the schedule to do that tomorrow. So that's what I do for my weekends. And then in the background is Dan Carter, just so people know your voice. Dan, you want to say hello quick?
Yes, good evening, everyone. Happy to be here. I'm looking forward to talking about tailwheel aircraft. That's the next best thing to flying them, and should be a lot of fun. Thanks for having me.
Yeah, thank you, Dan. He's going to be the producer in the background, helping out with a lot of the questions and everything. I had mentioned it before, but Dan started flying because he bought a Cessna 120 years ago when he was a teenager, young adult, and that led to his entire career, and he's with us in the FAA as the Bradley FAASTeam program manager. We also have Tim Haley, who is an airworthiness FPM, but this is what Tim does when he's not on the airworthiness side, is he flies his own aircraft. You want to introduce yourself, Tim?
Sure. Hey, I'm Tim Haley. Like he said, I'm out of Greensboro, North Carolina. I'm in a super decathlon right there. So I've got some tailwheel experience. I'm going to talk a little bit tonight about some of the maintenance issues that come up being a tailwheel aircraft. I think you were just bragging there a little bit, talking about flying that L19 and a Beech 18. You know, I'd probably kill to fly either one of those. So, but yeah, so I'm looking forward to it. Let's get going.
Yeah, and believe it or not, a lot of, to make all of us jealous, a lot of the information that was given to me by our compatriot, Bob Hill, who's the FAASTeam program manager for the Nashville FSDO. And Bob, for many years, flew B-17s on the weekends in DC-3s. He was the national resource for the FAA and the B-17 for many years. So Bob and I have talked a lot. Some of the pictures here come directly from him. Some of the B-17 pictures are him actually flying the B-17. So, there's a wealth of experience across the country on this. And we do want to thank you for joining us. This is a Wings event. We will upload credit probably Monday, I would suspect, at this point in time. But if you're not familiar with the Wings and the AMT program for the maintenance types, please do go to FAASAFETY.GOV and learn a little bit more about them, because a proficient pilot and a proficient mechanic do really well. And we want to thank you for joining us on part 1 tonight. Normally we would be doing this in person like this, but we have to do it online, but we're able to open it up. We got about 200 of you out there with us now. But not only do we need part 1, all of us need part 2. No matter what type of aircraft we do fly in, is a good pilot is a proficient pilot and practices their skill as much as they can. And one of the things many of us like to do is acquire new skills. And for tailwheel flying, that's one of the things it can do. A variety of different types of aircraft, all tailwheel equipped, with all differences associated with them. We'll talk about the advantages and even some of the disadvantages associated with tailwheel aircraft out there. And what is involved with it, because there's so many factors, and that's why you need to get good training with it. And I, even being a glider type, I used to teach in motor gliders first before I got into straight gliders and taught in these 3 types. It can be very, very different over there with long wings and everything else. And comparatively speaking, you don't see, although there has been a resurgence, I think, since the light sport aspect of flying and a little bit more of the recreational, a resurgence in tailwheel aircraft sales. But years ago, the manufacturers got out of it because they figured out the Land-O-Matic landing gear, or as I used to call it, the auto alignment feature for crosswinds. Is from a perspective, it did reduce the number of insurance claims, that we were having on aircraft. It did reduce the amount of bent metal from time to time, but it doesn't always work perfect for the best of situations. And even back before World War II, we started seeing some tricycle gear showing up. Many of us will recall the Coupe, the Bonanzas, the Tri-Pacer, even the 172 came out of the Cessna 170 with a nose wheel design. And that's what the manufacturers were going through. What we want to achieve for you tonight, hopefully, we can't cover everything. There's a lot we're going to miss, I know, but we're going to try to give you a good broad overview. But understanding some of the differences between a tricycle gear airplane and a tail dragger, talk a little bit about the decision making associated around tailwheel flying, some of the training challenges. We'll talk a little bit about the regulations where the FAA, we have to cover that dry stuff, but nowhere near is this a substitute for competent instruction on tailwheel. That's all that you have to go out and seek, and especially recognize it doesn't work. What we talk about and what you may learn in one tailwheel aircraft doesn't work for all the tailwheel airplanes. There's some big vast differences out there. So I want to go ahead, let's just open up that first poll question. This is just going to give us a little bit more of an opportunity to let us know about you. And we do have just about 200 of you out there. I'm distributing the poll. We want to know why you're here tonight. What are you interested in? So I'm going to give you just about another 40 seconds to answer this. We're through 40% of you now. We're coming up through 60%. Folks, this is your chance to practice for November. Vote early, vote often. Who knows? With all the coronavirus that we're dealing with and stuff, maybe some states will be using online polling for voting. Who knows? But we will take a look at it. All right. We're right about at 1 minute. We got 73% of you. One or two more. Come on, make 75. There we go. I'm going to go ahead and close it. So we got 75% of 200 people. I will share that with you. And Tim, because it is hard for me to read this, I'm going to ask you to help me out and just talk a little bit about what we have for the spread of people on the answering. Can you hear me, Tim? Or how about Dan? Dan, can maybe you help us out?
Yes, sir. Sorry about that. I was working some questions and answers. Okay, so I'll run the poll for you. So I am interested in tailwheel flying because, first place was I fly them regularly, which is awesome, 30%.
Excellent.
Second place, 29%. It's a lifetime goal. It sounds like fun.
It is.
And then after that, we have I fly them occasionally. And then at 12%, I just want to see the difference. I'm a truck driver and want to see what it's all about. And then in last place at 3%, they work better for my type of flying.
Okay. Well, and I put these answers in specifically to try to give a little bit of perspective. That 30% that fly them regularly, if they're out there doing that, they're probably the proficient ones. Flying them occasionally, you're going to really need to make sure that you have a program set up that you are going ahead and getting some very competent instruction and some checking with it. I do that myself. Once a year, I get together with an instructor, even though I fly a few different types regularly. I get together with an instructor and a tailwheel once a year just to kind of double check myself and make sure that I am doing it right. And I do change even that type around. And, you know, the I fly them regularly types are normally the people we don't worry about. It's the people that are new to the aircraft. You know, I have to play a little bit of the safety aspect to it here, you know, but the types that maybe later on in their lives, oh, I always wanted an airplane like that, and they go and buy it. That's what some of these are just a few, I emphasize a few, not all, of the tailwheel type of events we've had in the Boston FSDO in the last 2 years or so, you know, where you'll notice we've had a tendency to either break landing gear off of them or tip them up on their nose. And you want to be very aware of that, you know, and this is the aspect, the safety thing I have to mention. You know, this is the FAA side of me is, are you really ready? If you're going to be flying tailwheel, are you ready to commit to the amount of practice that is required? Are you ready to commit to the additional insurance? You know, for ground loops, there's kind of that saying, just like on retractable gear, there's those who have and those who will. And it's interesting. I was talking to a compatriot of mine recently where I just got a quote on a tricycle gear version of an aircraft, and he has the tailwheel version. Basically, it's the same standard airworthiness certificate aircraft, and his insurance is 300% more of what I was quoted. We're both regular pilots, been flying for many years, have many, many hours, both instructors, all of that. But, you know, just because of tailwheel, he's paying nearly 300% more on insurance. Also, you know, are you ready to recognize that one tailwheel does not equal all? I know I'll readily admit within the FAA, we even deal with this. The National Resource Office sends me some things from time to time. And like, I know a couple years ago, they sent me a Waco check ride, you know, and I've flown a Waco, but it's been like 20, 25 years. And I went to my boss, I'm not jumping in one to do a check ride without, you know, some recent practice in one. And even my boss was happy because he sent it back to the office. The manufacturer had a letter on their website saying, please do not get on our aircraft unless you have within the past year had recent training in one of our aircraft. You know, so it does make a difference, you know, and that the endorsement does not make you proficient. And this is, I know it's a little bit of a Debbie Downer, but I've had to have this discussion with people. I'm in that older bracket now, and many of us as pilots are. You know, you have to be ready at some point in time to recognize maybe those reflexes that you might need in that good crosswind are not as fast as they once were. And, you know, if you're going to be flying them regularly, you need to be ready to probably give it up at some point. So there was the down part. Now we're ready for the happy parts to all of this, you know, this is why we're all here to it. The tailwheel advantages, you know, in general, what we do find, why we end up seeing them still being built, why people like them, they're easy to make, they're easy to put together. A lot of times it's fairly easy maintenance on them, and everything's out there in the open for you to see for the most part too. You know, they weigh less, it can increase your useful load, it gives you greater cruise speed usually. And typically, depending upon the type of flying that you're doing, the tailwheel will probably require less maintenance as you go through it. And a good example, you know, Piper did this. They had the pacer and the tri-pacer, you know, and the pacer itself, just with that thing moved from there to there, you know, it gives you a good 8 miles per hour or so in speed. Same aircraft all the way around, just it's going to go faster. And today we're seeing a resurgence of people taking these and converting them back into those. you know, taking the PA-22s and converting them back into a PA-20. You know, some of the other advantages, you get greater propeller clearance, especially if you're operating in different types of terrain. I used to do a fair amount of ski flying here in New England, so it does reduce your chance for damaging the propeller. You will need tailwheel endorsement, but you don't need a ski endorsement. Many countries do require that, but if you're flying off of ice and skis, it's not required. But like many other things that we do, I would strongly, strongly encourage you to get some good training on that. It really, really will make a difference. You know, and one of the other things, if you're getting into it, this is one of my aircraft that I would love to build, probably along with another 200 of my closest friends out there right now are thinking the same thing, you know, but I have flown a lot of the Kit Foxes. I like them. They're terrific, fun aircraft. I've been impressed with them in many, many different ways, but you can see some of the differences in performance and also figure out what you need. A lot of people want this right here. You know, they like the big tires and everything, but when you sit down and you start thinking about it, do you really need, you know, that difference of 140 feet in your takeoff roll? Are you always flying in areas where you're going to need those big fat Tundra tires? You know, do you need that difference in your landing roll? Or even along that same lines, you know, do you need the extra speed of a clipped wing version to it? You know, that's going to change your takeoff roll. It's going to change, you know, the speeds at what you're touching down at, which can have an effect on the landings and the type of landings that you may end up doing. Tailwheel, everybody says, oh, I need it because I'm going to be flying off of all of these backcountry strips and all of this sort of thing. And most people, when they do come down to it, recognize that's not always the case. So when you do think about tailwheel, you want to think about it in terms of the performance that you need. And many experimental aircraft manufacturers offer that for differences. You know, the RV-8, a terrific, terrific experimental amateur built aircraft. You can get it in both versions, you know, tricycle gear or a tailwheel. What is it that you really do need out of it? Are you willing, you know, to sacrifice some things like maybe insurance costs, you know, in order to get that extra speed, or, you know, the sexy appeal of the aircraft, maybe, as some people attribute it to? And do recognize, you know, I can go the other way. You don't see very many jets that are tailwheel. You know, the Germans tried it at first and found out, boy, this really does not work. We do a pretty good job at burning up pavement and everything else. And so after some of the initial testing on their, you know, 262, or that's not the 262, is it? I'm sitting here, I'm having a brain fart. But you know, they switched over to the tricycle gear. It just worked much, much better for them. And you know, what is good is it's simple enough. You know, or the tailwheel is, you'll see other things. This aircraft used to be based just about a half a mile up the road from where I am right now in Paugus Bay, New Hampshire, Laconia, New Hampshire, doing airplane multi-engine land and airplane multi-engine sea ATP trek rides. You know, and here you have the factors of multi-engine, you have the factors of a flying hull seaplane, and you also have the factors of tailwheel. It can make it very, very interesting. Now, there is a regulatory part to this, and this is another little part where I have to play the FAA part to this and, you know, take that delightful road down the legalese. You know, in order to act as pilot in command of a tailwheel airplane, you know, and I emphasize airplane, we'll get to that, has received and logged flight training from an authorized instructor. Now, who is an authorized instructor? It's someone that that holds the appropriate flight instructor certificates with appropriate ratings, and also has the endorsement or meets the requirements of this regulation, 6131 paragraph I, and also received an endorsement in the pilot's logbook who found the person proficient in that. Now, when you take a look at the reg a little bit more, it says it must include the following: normal and crosswind takeoffs, wheel landings, unless the manufacturer recommends against it, which I have come across some aircraft there with wooden spars where landing blocks are attached to the wooden spars, and go-arounds. But you got to realize, is that really enough? I use these two pictures because some tailwheel aircraft behave completely differently on pavement than they do grass fields or gravel fields. Is that something you're going to touch upon in your training? They behave differently sometimes if they're tandem with one or two people in them. Also depending upon where the fuel is located in the fuselage. Or I think this is an M4 by the looks of it, if I recall correctly on the ball. Even as the design of the aircraft matures, there may be some change in directional stability on the aircraft. So you got to ask yourself, if I'm going to go out and do this, am I going to get the appropriate training? Now, there is a little grandfather clause to this, and I do fit this grandfather clause myself. It's how I actually operate with tailwheel aircraft. Is if you did operate them as pilot in command before April 15th, 1991, you basically automatically have it. But I will also readily admit, I took about 10 or 12 years off from tailwheel flying. Flew exclusively tricycle gear, higher performance aircraft, and then came back to the tailwheel. And boy, that first time back was an eye opener for both me and the instructor. Oh, you used to do this and blah, blah, blah. It is kind of like riding a bike, but on the other hand, it's not always like riding a bike. And Dan, we were joking about this the other day, right?
Yeah.
If you haven't done it recently, it's like, oh boy, this could be interesting.
Yeah. I had about a 20-year break in between, so yeah, I had an even longer break, and it was an exciting experience for all involved. And I noticed as an instructor, a lot of my older students, a lot of them learned to fly in tailwheel, like a J3 or whatever, and then came back to it in later years, and they were very surprised as well. So that's been my experience.
Yeah. Now, there's also some other parts of tailwheel flying in the regulations you want to be aware of, and that's the currency. The takeoff and landing currency is, if you're going to be carrying passengers as pilot in command or more than one pilot crew, like some of the larger multi-engine tailwheel aircraft that you'll see pictures of here, you do have to have done 3 takeoffs and landings in a tailwheel airplane, and they must be to a full stop. You just can't go down and basically do like a touch and go wheel landing or whatever. You need to have done that. Now, here's one of the little stipulations that catches people's attention. All that's required is that you've done that in a tailwheel airplane in the past 90 days. The night takeoff and landing experience says nothing about tailwheel aircraft. If you've done those 3 takeoffs and landings in the past 90 days to a full stop in a tailwheel aircraft, by the way the regulation is written, you're fine to go do night takeoffs and landings. And this is one of the things you may want to consider in your training, is you probably ought to go out and do, at least if you're getting the endorsement, at least one lesson where you go out and do some night takeoffs and landings, because you lose so much of that peripheral vision and depth perception that it can make for some interesting bounces out there. And here's one of the things: just because it may be legal, that you don't have to go do the 3 takeoffs and landings to a full stop at night, in a tailwheel aircraft in order to carry passengers at night, just you need to have done them in the past 90 days, which could have been during the daytime. Is it legal, but really, is it safe? That's what you want to give some consideration to. Now, if we talk about some of the different performance considerations to all of this, when we look at a tricycle gear airplane, and especially off of softer fields, grass fields, gravel, things like that, there's a few things that you want to be aware of. Is you're probably familiar with the soft field technique where they talk about the flaps and getting the nose off. Normally, in order to do this, you're going to need a lot more down elevator pressure. And you may recall from your basic principle private pilot ground school is the total lift being produced by the wing has to equal the weight of the aircraft plus the tail down force that's required. If you have to increase the tail down force significantly in order to get that nose wheel off the ground, and also you have this larger nose wheel that has a tendency to kind of wheelbarrow down into the ground, it can create a bit more drag and lead to a longer takeoff roll than an equivalent tailwheel version of the aircraft. That's a factor, but not the only factor to it. So you might end up with higher takeoff speeds, a little bit longer takeoff roll in a tricycle gear than you may in a tailwheel aircraft. Whereas a tailwheel aircraft, when you're doing the takeoff, what you have to do is raise the tail so you don't need as much tail down force. As a result, you're getting the wing set up much closer to the proper pitch attitude and angle of attack for takeoff, is you may not need quite as much runway to it. And in relation, you're probably only really dragging two main wheels through the ground, over the grass, gravel, whatever it may be, versus the three of a tricycle gear. So, equivalent airplanes, you're probably going to find a little bit better takeoff performance and if not landing performance for the tailwheel than you may for the tricycle gear version. But also, as things change in our world, you may have already noticed this, and we'll hit upon kind of the why, is when you look at the drones, very, very few, if none, if there are any at all, are tailwheel. They're almost all tricycle wheel. And you got to think about that is on the landing aspect, there must be something that's beneficial to most operations for the drone where the pilot is not right there and they need to have a larger scope of errors that it can handle, that the tricycle gear works a little bit better. And there's kind of like two things we'll just talk about a little bit that can be a little bit of the nemesis for the tailwheel pilot. One is the directional control. Is if you do take a look at the wind and how much surface area there is on the airframe behind the pivot point of the wheels is the main wheels. You take a look at it. And so from this point all the way back, there's all of this surface area that will make the aircraft want to weather vane into the wind as compared to a tricycle gear aircraft. And that can be pretty darn significant for us. So, there are even some aircraft, like I used to teach in the aerobatic Cap 10Bs, which had the giant rudder on them. And the demonstrated crosswind component was 25 knots. And yes, you could land them in a 25 knot crosswind. But when you got down to 10 knots, the only direction you could taxi was into the wind because it would end up pivoting and weather vaning into the wind. So here, if you take a look at it, the center of friction in relation on the tricycle gear airplane, you have the nose wheel that's providing some friction to it. Also, you have the main wheels, which are set further aft, and the center of gravity is right down there in the middle. And weather vaning tendency, only this portion of it, of the airframe, is sticking out in the wind. You have all this on the front end balancing it back. Whereas on the tailwheel version, the main wheels are moved forward. You can see you have that much more of the fuselage behind that point and where it will want to start to pivot. And then also, as you're touching down, and this is one of the things to really think about, and these are simple diagrams. They're very similar to a book called the Complete Tail Dragger Pilot that I've used over the years as kind of a training manual for teaching people to fly tail wheels. Is you end up going out there, and in a tailwheel airplane, as long as you have the direction of travel, aligned right in between the two main wheels, you'd probably be fine, i.e. good crosswind technique. But with your center of gravity behind the main wheels, is if you don't have good technique, what can happen is as soon as the direction of travel line from the center of gravity gets very, very close to one of the main wheels, if not past it, we start to see the aircraft wanting to try to swap ends on us. And this is different. Each aircraft is a little bit different in how it will behave. Also, tandem aircraft is if you have one person up front and they're sitting right here, you have a fairly forward CG, not that big of a deal. Now you're carrying baggage in the back along with a person in the back seat. That CG has moved further aft. A good example of this is like the Cessna 185s. Is you fly those with just yourself in them, pretty straightforward, pretty easy. Especially, you'll notice it on pavement. You get it all loaded up near the aft CG, with 4 or 5 people in them, plus a little bit of baggage, hardly any fuel, and you'll end up finding yourself that tail wants to come around and get out in front of you. I know I was working with someone on recurrent training a little over a year ago in the L-19, and he had been flying the L-19 for like 6 or 7 years. And I had said to him, well, you fly it mostly by yourself, but you'll see I'm in the back. I'm a bit bigger than you are. You're going to definitely feel that. And where you're really going to feel it is on pavement. And he's, I've never landed this on pavement. Aha. We now have a task for today. So we flew to a nearby airport and we did a couple takeoffs and landings there, coached him through it and everything. At the end of the flight, he was like, thank you, thank you, thank you. He's like, I never would have suspected that aircraft felt that different with someone in the back and taking off and landing on pavement. Just with that change in the CG. It's one of those things in your training, you need to experience it to see how much of an impact it has. And if you do go out and buy a tailwheel aircraft, which I hope you do, they're a whole lot of fun. That's something you need to think about, though, in your training. Get together with a competent CFI and learn about how it behaves in the different weight conditions and different runway conditions. And here's a good example is every tailwheel pilot right now is looking at this going, ooh, I know what's coming up next. And it's a good little excursion off into the grass with maybe ending up looking back at the approach end of the runway versus the departure end of the runway. Tricycle gear, from the ground looping, they have what I always have called the auto alignment feature to it. A tricycle gear, you do want the good technique, say in a crosswind, where you're correcting for the crosswind. In this case here, we'll say from the left, and your direction of travel, with a little bit of the slip in, is right down the longitudinal axis of the aircraft, lined right up, and you have your center of gravity between the nose wheel and the main wheel. But the design of a tricycle gear aircraft is if you land in a little bit of a side load like this, and especially are holding the nose off as you should be doing, the friction on the main wheels with the center of gravity is going to try to swing this aircraft back into the direction of travel. You know, the auto alignment feature. You know, we've all been at airports and probably seen some ugly landings. We've all been students at some point and done some of those ugly landings. But this is the difference that we see between a tailwheel aircraft in that circumstance where this wants to swap ends and the nose wheel aircraft where it wants to auto align. Always, and especially in the lighter aircraft, proper control deflection during taxi is very, very important. You know, a simple way to look at it is, I always say to people is, you know, you want to turn into and try climbing with a headwind from whatever side it is from. And with a tailwind, you typically want to turn away from and dive away from it. So if you have, you know, a tailwind coming at you from behind on this side, you will want to displace the stick forward and off to the side here. We cover this in basic training. We cover it for tricycle gear aircraft, but it is so important in tailwheel aircraft. You know, I can't emphasize it enough. I know, as you heard, I used to teach and I oversaw a bunch of instructors in some Cap 10 aircraft, Cap 10Bs. And I can remember one day it was like 18, 20 knots of wind and one was taxiing out. And I can remember watching it going by the window of my office thinking to myself, well, I hope that they really are always thinking about the wind right now, because the tail could get picked up on them fairly easily and all of that. Well, they started their run up or pulled down into the run up area, and then they were using proper crosswind technique for the taxi, but then forgot about it as they started the run up. And what happened? Gust of wind came, blew the tail up right in the middle of the run up. They went up on their nose, you know, hit the prop, engine tear down, all that fun stuff. You know, and just a little distraction like that can be expensive and can make you not so happy, make your insurance agent not so happy. And this one, I was one of the first people on the scene of this accident at Oshkosh years ago. You know, a very horrific accident. I don't want to just describe what it's like. And I actually knew the pilots of the TBM also in relation to this. They were based at the airport that I used to be based at before that. But some aircraft, it's very difficult to see over the nose for tailwheel aircraft, especially like the older warbirds like this. And this was an accident that occurred at Oshkosh back in 2006. And what had happened is the TBM Avenger was following another tailwheel aircraft, a green and white Tundra. What is it? The Bush Caddy or something like that is another version of that experimental amateur built, when the RV6 was directed to taxi out in front of them in that gap of like 200 feet with them. The TBM pilots never knew they were there. They never saw them. They had been leaving a big, large gap purposely behind that green and white aircraft. And, you know, a younger person directing aircraft traffic for the departure, you know, said, oh, a big gap, put somebody in there. And they never did see him. You know, when the line came to a halt, they stopped and the TBM ended up going right over them. If they were just doing slight S turns of about 10 degrees side to side, they likely would have picked up and seen that aircraft, but they were just continuing straight down the runway. It will vary, you know, some tailwheel aircraft you need that, some you don't. You know, like your super decathlon, Tim, probably not a factor. You can see over the nose fairly well. Most people can.
Yeah, it's a good visibility out of the decathlon. That's what makes a lot of people like that.
Yeah, it is. That's one of the things I definitely will like. You know, and there's what's known as torque effect is the FAA's official mentioning of it, but many of us know it as left turning tendencies, but it's not always the case. You know, And it does depend upon the power of the engine too, and many other things, you know, and a good instructor will cover this with you, how, you know, one gear will end up as you're adding power, putting more pressure on, will have more friction with it. Talk about torque reaction of the propeller blade as you raise, lower tails, all of those different things. But, you know, probably the most common thing is right rudder, right rudder, right rudder for us in US aircraft. But some aircraft like the Wilgas, I've flown those, you know, the Grobe 109s, engines may turn the other way. And where it might be right rudder, it may be left rudder. And I will readily attest is if you're flying multiple tailwheel aircraft, and sometimes even in the same day, and one requires right rudder and the other requires left rudder, you know, you're like, okay, this is a left rudder aircraft. I have to remember when I raise the tail to apply left rudder, you know, it is. And what I'm emphasizing there is you need to know the tailwheel airplane that you fly and know it very, very well. What is great about tailwheel aircraft is they will teach you what your feet are for. And especially if, you know, I live very close to the Alton Bay Ice Runway. Some of the airports near me look like this in the shoulder seasons, you know, where we get a little bit of ice and stuff on it. And you're really gonna have to learn how to use your feet in a tailwheel aircraft, and also for the given conditions, and also for the design of the aircraft. You know, you want something a little bit funky, you know, in terms of the impact that the design of the aircraft may have on how the aircraft behaves. You know, you look at this, which is a Schweitzer aircraft that was built for very quiet stealth observation before drones really came into being. Look at the size of the vertical stabilizer to it, you know, to provide some directional control with the rudder, the size of that, but also think about the weather vaning tendencies. You know, you notice tailwheel aircraft, you also notice chunks of mass, such as the propeller and gearbox, way out here on the nose, you know, and think about the momentum that can occur in a bounce or anything. You have an engine that's behind the pilot and much further behind the main landing gear, and is also propped up higher in a pylon on the fuselage. Then think about this is because these were stealth observation aircraft, they literally did have glider wings to them, you know, that were changed over for fuel, you know, and have fuel. You now have large masses of fuel and large, you know, 60, 70-foot long wingspans out there. In fact, you know, some of you may recognize the name, but Jim Beatty of the Beatty aircraft fame, or infamous, however you want to approach it, he actually had gotten a hold of one of these aircraft and was trying to modify it even further to be able to do the first around the world non-stop, non-refueled flight, to give you a little bit of an idea of how different or unique some tailwheel aircraft can be. Also, some other things with tailwheel aircraft, I use this. I'm in the L-19 a lot the last few years, been in Cessna 180, 185s over the years. But, you know, Cessna kind of learned this. The old Cessna 170s and the L-19s had the rounded tail, and especially the L-19s with 60 degrees of flaps. You take a look at where those flaps are and how much of that tail you can see. You know, I actually end up doing almost all wheel landings in the L-19 with the 60 degrees of flaps with a tail up fairly high for the corrective action to it, you know, the airflow over the tail. That's one of the things that when you get it low, I find the flaps just block it out and you have very little directional control. Cessna did change it from the 170s to the 180s to the 185s, went with the more vertical tail, vertical rudder, and also did reduce the flaps a little bit too. But that improved, you know, how much of the tail was in the airflow in the approach and landing and made a big difference. In fact, there are a couple places that do major modifications to the L19, and that's one of the things they recommend the most. And the US sold the rights to build them to the Italians, and there's an Italian version of the L19s, and they all have the square tail like the Cessna 180, 185s. Other aircraft that are popular might have some little fixes to it. The Cessna 120, 140 is a good example of it. It has the landing gear extenders like you see here that bolt on and move the landing gear a little bit further forward to give a little bit better directional control on the landing with it. That was something that they tended to tip up on their nose quite a bit, because the engineers for directional stability in flight had to put the gear back a little bit further than they actually initially wanted to, but that led to it tipping up on its nose quite often in the landing. So someone came up with this handy little feature here. And we're talking about tailwheel, but there really is. There's tailwheel, there's tail draggers, there's even some aircraft out there with rudder wheels, where the tailwheel is mounted on the rudder. This is a Funk that has a similar type of design, but not truly set up there. And I joke, this is a call air, not this particular one, but I know I was flying behind one in a glider this past winter where you can literally have a tail wheel one moment and have a tail dragger the next. Is we're taking off and there was a broken bearing in the tail wheel that didn't know about, and we took off and I said, his hat fell out. And then as it bounced and went by me on the runway, I noticed it was the tail wheel and the tail wheel fork, and I had to call back and say, hey, Joe, just so you do know, you just lost your tail wheel and tail wheel fork. So, instead of it being a tail wheel when you land, it's going to be an absolute true tail dragger, and you may want to land on the grass. And even, with a lot of older aircraft are tail wheel aircraft, and many of them also have systems that you may not be used to. A lot of the older aircraft have heel brakes, and even some of them, instead of having a hydraulic type of brake system, will even have like cable heel brakes on it, just almost similar to like a bicycle brake that you may see, and that has stretches with it and everything else. So as you get into tailwheel aircraft, you really have to start thinking about some of the maintenance aspects of it, and even in the design of it. And that's where I'm going to turn it over to Tim here.
Thanks, Steve. Let me get this set up right quick.
Okay.
Let me. Should have my screen up there now.
It looks like it to me.
And one more. Okay, so let's talk about tailwheel geometry just a little bit. It comes down to geometry as the basic steering geometry is what we're talking about tonight. Tail wheels with a positive caster are good. Positive being the pivot line being ahead of the vertical line from the pivot point to the ground. So we'll talk about that here just a little bit more in a minute. Tail wheels with a negative caster, now that's bad. The negative being behind that vertical line. We'll talk about it. We're going to show you here. The next slide's got a good example how you can do a quick, easy check on that. So in the picture right here, in the lower picture, you can see there is a line coming straight down, and this is the pivot axis line. And this is the line that they drop the string. They use the string to drop a line, and this is where we talk about a positive caster angle is right here. Okay, so in the top photo, you can see that that line is behind it, and that's where we get what we're calling the bad caster. This is where the shimmy is going to come in that landing gear. See if I can't make it a little clearer. Here, we're using a square just to make it simple for you to get that line so you can see where that vertical line would be right down this edge. And this green bar represents this pivot line that you see right here on the left side of the picture. That's where it's pivoting at. The fork is pivoting on that tail wheel assembly. So when we talk about having that positive line, we're talking about the bolt head should be on this side of that line, and where it comes in and mounts, the nut is going to be on this side of that line. That creates that positive line where we tend to not have that castering effect. You got to think about it like a grocery cart. You know, how many of us have went to the grocery store and we've got a grocery cart and that front wheel is bent back a little bit, so we've got a negative caster line right there, and we're pushing it through the grocery store, and the whole time that thing is shaking and spinning and, you know, creating all kinds of problems. So now you would sit there and think, well, let's make that caster angle be great. Well, that's got its problems too. You don't want that caster angle to be too large because it will make steering on the ground more difficult. The large caster angle will tend to lift the rear of the airplane slightly as you turn the aircraft. This is called the self-centering effect. Having the steering axis bolt vertical or inclined slightly with the top pointing back when fully loaded should be sufficient. So, you know, there's a lot goes into the effects in here. You know, what makes a difference? So we've talked about the fact that we've got to have a positive caster angle, but what would make that change? Well, the leaf springs. If the leaf springs that's going from this tail wheel up to the fuselage, once that leaf spring starts getting some wear in it, starts getting weak, it allows his tail to start sagging down. My airplane, I can tell when my tail wheel tire is starting to get low on pressure, because anytime it's below, it's low on pressure, I start getting tail wheel shimmy on landing. So you got to think about it. You know, when that tire is starting to get low on air, this rim is coming down closer to the ground. And when it starts coming down, then we're changing this angle up here. And that's what it's all about. It's changing that angle. We want to do what we can to stop that from happening. Weight, you know, we talked about weight in the aircraft. You could go back there and check that caster angle on the landing gear and it'd be correct. But once you start putting people inside the airplane, if that leaf spring has not got the proper tension on it and it starts letting the tail go down, now we're changing that caster angle. Same thing when you're landing, you're rolling out on the runway and you're putting too much back pressure on that tail, you're changing that caster angle as you push down on that spring. Right here on this is a type of tail wheel you see. I see this on a lot of sport aircraft. It's got a hard fixed rod for steering. There's no play in there. And once this thing started having a shimmy, we had no choice but to break that steering rod that's coming down. You know, I can imagine the rudder pedals in there. In my airplane, when I've got a tail wheel shimmy, I can feel it in the rudder pedals, but not like you probably felt it in this one. Maule Tailwheel. Now this has got a lock and tail wheel on it. The lock and tail wheels, you know, that's for takeoff, for landing, to keep that wheel straight, to help assist the pilot going down the runway. Some of them have a cable where they engage and disengage. I think on this Maule, and correct me if I'm wrong here, Steve, I think on this Maule, it's automatic, or you have a cable controlling it?
No, there's no cable control. What it is it it is designed so that it will try to add extra friction by the cam in it when it is straightened up. So you get a few degrees off and put too much pressure on it, it will pop out and start to become like a free castering tail wheel. But it's designed that it will primarily try to stay in line through the cam fixture on it that you can see over on the far right hand side. And these are terrific, simple design tail wheels that work well as long as they're also checked and kept clean. Is some of the issues that we have, and you know, if you fly Maules and you talk to people that fly them, you know, you'll know that there's quite a few people that have changed out their Maule tail wheels and put some other version of tail wheel on their Maule over time. And probably the reason why is it's just because they haven't kept track of it, made sure that the tension of the spring that you see on the far right-hand side is appropriate, that that spring has not been, over compressed, shrunk down, that the cam and lock in it has not been worn down too much. And the middle one that you see here is the little plate cover that goes over the spring. If you operate in and off of a lot of dirty runways, grass runways, dirt, gravel, whatever, which actually are pretty popular for the Maule aircraft, you get this all gunked up, and the grease in there can start to collect dirt, and it can stick. And we end up having some people that ground loop just because they haven't properly maintained the tail wheel, haven't been checking the tail wheel as regularly as they should, haven't noticed that the cam has worn down and replaced it. All simple things to do, but if you're not doing them, it can end up leading to something much more expensive, like bent wing tips, bent propeller tips, than just what it would take to go ahead and be doing the proper checking and maintenance on the aircraft.
Yeah, that's all good points right there. And you brought up a couple other things. Even on that Scott tail wheel that was 2 pictures ago, you have a center detent on that. And that's another thing they need to be checking at the annual inspection is like on the Decathlon, we've got a breakaway tension. And there's a check for you to do where you check that tension to make sure you've got the correct breakaway tension. And that's to help you on landing so that, that helps makes it just a little bit harder for that tail wheel to start, for that fuselage to start swinging around. So, that's another thing that I was going to add in on that picture you had about showing where the center of gravity is you need to think about how much weight is on that tail wheel versus how much weight is on a nose gear.
Yes.
The average nose wheel tricycle airplanes probably got close to 1,000 pounds on that nose wheel, whereas that tail wheel aircraft's only got about 150, 200 pounds on that tail wheel. And that's another reason why it can swing that tail around. Even if the tail wheel don't break loose, you can start sliding that tail sideways. So it's just things to think about when you're coming down that runway. Not realizing when to abort. Unusual noise, abnormal acceleration, strange vibrations, early stages of lost control. Failure to maintain directional control causes loss of control and excursions from the runway. Failure to compensate for wind. Recall too that as the airplane nears rotation speed and becomes light on the gear, it's more easily displaced and intolerant of poor technique. Applying throttle too rapidly, raising the tail too abruptly induces rapid directional control changes that may not be captured in time, especially as we get older. These could force the pilot to overcome, compensate, or compensate incorrectly. Failure to maintain proper takeoff attitude, raise the tail too high, increasing the takeoff roll while becoming increasingly unstable. Moreover, depending on the type of gear, some spring skill or bungees, applying too much forward stick pressure and then relaxing it could induce the crow hopping effect. Leaving the ground too high at an angle of attack close to the stall speed could cause settling down on the runway. Releasing back pressure too rapidly after lifting off may cause impact with the runway. Using brakes to preserve directional control. Mechanical heel brakes on Cubs, Champs are best avoided during takeoff and landing. Another issue is putting the tail down on the ground too fast. You still got too much airspeed. You need to make sure that, if you're still above the stall speed and you put that tail on the ground, you've just put the wings at the perfect angle of attack, and most likely you're going to be flying again. Maximum performance takeoffs are procedurally no different than those executed in a tricycle gear airplane. Recall that a soft field doesn't have to be physically soft. Grass strips may be hard as concrete. A soft field is any surface that creates excessive drag on the landing gear. Grass that needs to be mowed, snowed on a hard surface runway. Common technique for soft field departure is to initially raise the tail slightly to minimize the frictional resistance of the tail wheel. Another acceptable method is to allow the aircraft to come airborne into 3-point configuration at the wing's maximum lift angle. One must then judiciously lower the nose and accelerate to the desired climb speed. Short field may or may not have obstructions. Soft field departures may be executed in the same manner. That brings up one more point that you talked about early in the presentation. I went on a tailwheel accident. A owner had just bought a Maule. He never flown a tailwheel airplane, and he got a CFI, and he got tons of training in this Maule. And he was good flying it. He could land it perfect. But during his training, the CFI never once took him to a paved runway and let him land that Maule on the paved runway. And the first paved runway he sat down on, he ground looped the airplane, and we come out and did the investigation on it. So,
Yeah.
like Steve, go ahead.
Oh no, actually there's a picture of a Maule in here that I know the pilot, and he upgraded his Maule, and he went for those bigger Tundra tires and went with the double puck brake option. And one of his first times with the new airplane on pavement, he was taxiing, and he was accustomed to his older Maule with single puck brakes and the smaller wheels. He hit the brakes fairly hard, and in the new one with the big Tundra tires, up higher, more momentum, and the brakes that just grabbed instantly, up and over on his nose he went. I don't even think he had 10 hours in the new airplane. He was just like, oh, what was I thinking?
Yeah, I did a beach stagger wing, and the airline captain went and bought this beach stagger wing. The guy that was selling to him took him, flew him around the patch a few times, said, man, you're a natural tailwheel pilot. You'll be good. He brings it back. Now, I don't know if you know a lot about the beach stagger wings, but they're really sensitive on their brakes. And he come back to his home airport, landed, and I guess he braked too hard, went off to the runway, and then through some culverts and ditches, and pretty much totaled that Stagger Wing Beach. It's still not flying even till today. And one more thing that you brought up is sight picture. You were talking about the sight picture in the airplane, seeing over the nose. Another thing you got to think about is the sight picture from the front seat to the back seat, because I fly my decathlon from both the front seat and the back seat, and I would swear I'm in two different airplanes because it seems a lot different when I'm landing it from the back seat versus landing it from the front seat. So you've got to take all that into account when you're flying.
Yep. And it's something I've taught a lot of instructors in, like the decathlons and stuff, little things that why you need to get a good tailwheel instructor for what you're doing is for the people transitioning to the front seat to the back seat. They don't realize that the trim is now controlled from the back seat, like in your aircraft, with your left toe. That you push it forward with your toe and then get your toe up behind it and pull it back towards you in order to trim the aircraft when you're flying it from the back seat, because you don't have a trim control in the aft seat. Little things like that's what's, I think tailwheel aircraft have a lot of those unique characteristics.
Exactly. When my CFI stuck his foot up there and moved the trim, I was thinking he was the only one probably ever did that. So I don't know, maybe not. So let's talk about wheel landings. We're using wheel landings to acquire controllability, crosswind. Talking about, you can go out there and interview 100 tailwheel pilots, and half of them are going to say, well, you got to wheel land it in a crosswind, and the other half's going to say, oh no, you got to 3-point land it in a crosswind. I found as many guys going for one side as I do the other, and I think what I finally decided is it comes down to which style you're proficient at is where you feel comfortable doing that crosswind landing at. So wheel landings, you come in slightly faster with power down the runway. You're slightly forward stick pressure at touchdown. You need to move that stick forward to hold that main gear on the ground. Expect a longer rollout depending on the wind. Longer exposure to gusty winds. And also in some aircraft, he was showing you one before, the rudder was so much bigger. Some of them you got take into account of the fuselage block in the rudder, and on some of them you'll lose a little bit of rudder effectiveness when you're transitioning from that tail up to that tail down. My thoughts on that right is I don't spend a lot of time letting that tail come down. I don't slam it on the ground, but when I start transitioning from tail up to tail down, I go ahead and get through that and get it down. Okay, we just talked about most of this used to acquire controllability, crosswind, slightly faster down, power down the runway, rudder effectiveness. So now let's talk about three-point landings. This is generally the easier of the two styles to learn and the one that should be mastered first. The three-point landing, where all three wheels touch down simultaneously, or the tail wheel touch down slightly prior to the main landing gear. The mains will be forced down due to the CG being located ahead of the tail wheel. This is historically referred to as a full stall landing, and it's simply the attitude at which the aircraft rests on the ground. Visually, it's precisely the attitude revealed from the cockpit before the start of the takeoff roll. The wheel landing will always involve a three-point landing as the pilot slowly transitions to the three-point attitude as the aircraft's forward speed dissipates. There are variations of both styles used, such as tail low wheel landings where the touchdown occurs in the mains with the tail wheel slightly off the ground. Crosswind landings could compromise the combination of any of these. So touchdown without excessive speed. That's the one thing about the three-point landing. You've got the stick full back as you come in and land. So at the point that all three gear touch the ground, you are completely out of flying speed. Zero drift, tail wheel contact in first is okay. Gracefully fly full back stick. Like we talked about before, if you still got some speed, you got to watch coming back too hard with this stick too fast, or you're going to see that tail wheel start to shimmy. Preserve proper aileron correction. More thoughts about it. Trap the airplane heading with the rudder. Only try to stop the loss of directional control. Don't try to correct it. Use proper aileron deflection. Use throttles to effect control. Always be prepared to go around and have an alternate plan. I know that's one thing I usually do when I'm coming in and I've got a stiff crosswind. My plan is always to come down, check it out before I touch down. You know, I'm still 20 feet in the air. Have I stopped the drift across that runway? And if I have, then, you know, I'll go ahead and proceed with the landing, or otherwise I'm going around or finding an alternate airport to be heading to. You know, multi-engine airplanes, you know, you got differential throttle applications to conserve control. I've talked to a lot of guys that's flown multi-engine tail draggers, and they'll tell you that that's the best way to land a tail dragger because you can get out a whole lot of crab in there with the differential power in that. So I think that's pretty much about the maintenance part of it. I think Steve's going to talk to you just a little bit more about the wings program. Go ahead, Steve. So let's get out and fly regularly with your CFI. There's nothing like, you there?
I am back. I had moved the control panel and it was taking me a little bit to find it because it was not in its regular place. So go ahead, Tim. I'm sorry.
Yeah, go ahead, fly regularly with CFI. We can't overemphasize that enough. And that's what the wings program is all about. It's getting out there and flying with your CFI every 6 months or so, and not just flying with your CFI once every 2 years. You know, let's get out and get some of that extra training. Renew your biennial flight through the wings program. You can do that if you do the 3 proficiency flights in the wings program and you do the 3 training courses like we're doing tonight. You can get your biennial signed off right through the wings program. Perfect practice. You know, I can't overemphasize that enough, especially if you're flying a tailwheel airplane. You need to be out there practicing regularly to keep that 3-point landing and that wheel landing going regularly and keep it proficient. Get all this documented in the wings. Anytime you're flying with a CFI, ask him to validate the wings credit and get that signed off. So basically, we want to thank everybody for showing up tonight. You know, you're the reason that we're here. Without y'all showing up, there wouldn't be no need for us to even have a job. So, you know, I appreciate y'all's interest in aviation. You keep both of us employed.
Yeah, thank you very, very much. I will emphasize that, and I do hope that each of us, myself, Tim, Dan, are able to run into you at an airport here soon.
There's our phone numbers, our email address. You got any more additional questions, don't hesitate to call or email either one of us. We'd be more than glad to help you with any questions you got. I clearly know how to forward my email to somebody else, so just send me all you want. So, hey, Steve, thanks for letting me join in tonight, man. I've really enjoyed it.
Hey, thank you. Thank you. You know, we talk all the time and we always diverge off into, hey, have you been flying lately and all of that. And it classically diverges a little bit away from work into what we've been doing flying. And I was like, you know what, this would be a good opportunity for us to get together. And thank you for coming on board and helping me. You know, everybody here got a 2-for-1 deal, I think, tonight on this one. So thank you.